Hey everybody, it's Jeremy Osterberger with Big Magazine, and I'm joined today by Heather Lyons, Site Director for Seadrift Operations at Dow. So Heather, thank you so much for joining us today.
Happy to be here. Thanks for having me, Jeremy.
So Heather, I'll give a little bit of background on the site. So Dow's Seadrift site began operations in 1954 as a Union Carbide corporate facility and became part of Dow in 2001 through the acquisition of UCC. So the reason we're talking today is Dow has selected its Seadrift Operations manufacturing site in Calhoun County, Texas, for its proposed advanced small modular reactor nuclear project. And this project is focused on providing the Seadrift site, of course, with safe, reliable, and zero carbon emissions power and steam as existing energy and steam assets near their end of life. So Heather, let's talk about it. Tell us about this partnership with Dow and X-Energy and how it came about.
Love to tell you more about that. So, of course, as part of the Dow team, we are always looking for opportunities to both produce and provide our products in the most sustainable and most cost-effective manner. So with that, as part of our energy and climate team support, they were looking at options to both upgrade some aging assets across our global fleet, as well as find ways where we could provide a lower carbon footprint as we provided energy and steam to those assets around the globe. So because of that, advanced nuclear was something Dow was looking into and something we were considering as part of that future design. And it was that potential because of the ability to provide low carbon, but also reliable steam supply through the advanced nuclear designs. So with that, we started engaging with X-Energy and across the industry to see, where we had a close fit or where we could work together on that. Ultimately, Dow chose X-Energy because their technology is the most advanced option for both the safe, reliable, and then that carbon neutral power and steam for our site. So that combination really provides a unique fit with their technology for industrial use. Because with industrial facilities, we need that high reliability. We need that 95+% reliability in order to operate our facilities. But furthermore, we also need high temperature steam output, which again, the advanced nuclear design has the opportunity to provide in addition to the reliability and the low carbon footprint. So all of those things not only are important to industry, but they remain critically important to Seadrift Operations as one of Dow's global manufacturing locations as well. So earlier this year, as we continued that exploration and fit, Dow and X-Energy announced a joint development agreement where we announced our plans to demonstrate that first scalable, low carbon, industrial aligned power footprint in North America, and then specifically on the US Gulf Coast, but in combination with the US Department of Energy Advanced Reactor Demonstration Program. So that was another key element of the agreement that we came to with X-Energy. And so after review of all the sites and possibilities that were available in North America and through this program, Seadrift Operations was selected by Dow as the site to step forward with the design. And ultimately, the Department of Energy agreed as well. And so we became partners, both as X-Energy and Dow, under that ARDP program.
No, that's great, Heather. Thanks for giving us an update on kind of where this all came about. So Heather, you mentioned reliability is so important. Get into a little bit of the technical side of this. I mean, how is an SMR or a small modular reactor different from maybe a traditional nuclear power plant?
Yeah, you really hit it there as you describe that acronym, Jeremy. So it's the Advanced Small Modular Reactors, or SMR, are truly just the latest technology as it comes to nuclear energy. And they can come in a variety of sizes, options, I say capabilities, design details as you get into the intricacies of the cooling, et cetera. But as I mentioned earlier, the advanced nuclear reactor really provides that scalable output. So that ability to range across the needs of a particular industrial facility. For us at Seadrift, that specifically would be 320 megawatts of power electric that will be generated by a 4-reactor design. But that scalability ensures that we have power generation, but we also actually can have, the process heat that we talked about, the steam at the high temperature steam, and provide that for other and multiple types of industrial uses. So that gives that SMR technology that flexibility. Again, back to those key components: safety, reliable, and then obviously meeting the industrial user constraints as well, being critical components. So SMRs as a design, the kind of technology they could use a light traditional, they could use similar, I should say, to a traditional light water design, where they might use light water as the coolant. But they also can use other components for that coolant, such as a gas, liquids, metals, even some salts are options as well. For the XE100 design with X-Energy, we'll use helium, which is cycled through that core to absorb the heat of the nuclear fission, and then transfer that to the steam and power generation that's needed for the site. The things that make this technology so powerful, and I've said it a couple times, but I don't know that we can say it enough, is just that it's simpler, it's scalable, but also the safety component of it. So the design for the reactor includes a pebble bed reactor. And in fact, I have one of the pebbles here with me today, so I'll share that with you. This is the size, so just roughly the size of a cue ball of one of the pebbles that's housed inside that reactor. And then the fuel that's used for the fission of the nuclear portion of the design is all contained within that pebble. So the fuel containment itself now serves not only as the vessel for generating energy, but also continues as the containment vessel for the waste that's generated as well. So those products and that pebble is used in such a way that if cooling is stopped, the containment is all contained within the pebble, so they consider it a melt proof, right? So it uses the principles basically of physics to control the reaction that's going on, and that's part of the advanced design versus using mechanics like a traditional light water design would use to control the cooling and ultimately provide a safer design under any type of condition, or even under any type of adverse conditions that would be experienced in and around the facility from externally as well.
No, thanks, Heather. That's neat, and there's some pretty good insight there into how it all kind of comes together. So, Heather, can you explain why the Seadrift site was chosen for this project?
Yeah, well, Seadrift is ultimately an important manufacturing site to Dow, and important to us as we continue to serve customers today and also customers into the future. So with the need for future growth coming to the site, but paired with the fact that we had aging assets, aging steam and electricity generating assets on site, we needed a technology that would not only replace those assets, but provide us the capacity to grow for the future. So that gave us that capacity, the new assets gave us that future capacity, but also, and ultimately from our goals from a sustainability perspective, provide us with a low carbon solution to provide that as well.
Yeah.
The other piece that's important for Seadrift is our region does have some experience with nuclear technology, not just across in Matagorda County. We have the STP, or the South Texas Project, which is a nuclear facility in Bay City, Texas as well.
Oh, very cool. So let's talk about the timeline of the project. I know the construction on the 4-reactor project isn't set to start until 2026. Do I have that correct?
Yep, you're correct on that date.
So we're in FEED right now, or tell me where we're at in front end engineering design.
Yeah, great question. Because it is, with any type of nuclear project, is a lengthy process as we go through the permitting as well as the ultimate construction and build. For our project, we are currently in I'll call it the pre-licensing engineering work as well as the permit application process. So the permit is the first step really to solidifying that next phase of construction, and that being the permit with the U.S. Nuclear Regulatory Commission. We expect to submit our permit application in 2024. Ultimately, then with the timelines expected as that goes through both the Department of Energy and the U.S. NRC regulatory review process, we are anticipating with the approval of that permit, construction would be able to begin, as you said, in the 2026 timeframe, which would allow us to bring assets online and ultimately have the reactors running at the end of the decade.
Wow. Okay. So that's kind of the timeline to do a project like this. So.
Yes, and certainly gives us a lot of time as we're working through those pieces, and we continue to engage with our local agencies, the national agencies, to ensure we have both our county footprints that are needed, all the requirements and regulations met from both U.S. and Nuclear Regulatory Commission.
Sure. No, that all takes some time. So Heather, can you go into how this project aligns with Dow's announced, decarbonize and grow strategy?
Absolutely. Well, I think Dow has been committed and quite in the forefront of ensuring that we have a goal to be the most customer-centric, most innovative, and sustainable material science company in the world. And as part of that, we need to continue to look for options to provide sustainable products, sustainable solutions, sustainable technology, both within our manufacturing footprints, but externally as well. So this project directly aligns with that because we are providing a lower carbon alternative, right, to the power and steam needs for our site, and also demonstrating its ability to be paired with industrial users of the future. With this asset replacement for us here at Seadrift, will significantly reduce our carbon footprint. In fact, we'll have a roughly 50% reduction in our carbon emissions for the site. So again, direct alignment with that corporate goal, right? Most innovative, customer-centric, and reliable, and sustainable material science company. So we're getting the carbon reduction, we're getting the sustainability. And when we put it to numbers, it's about 440,000 metric tons of carbon emissions per year that will reduce at Seadrift Operations as a result of this new project.
I love it. Heather, any last thoughts or anything else you want to share for our audience before we jump out?
I think what I would make sure the audience knows is that as we continue on this path, we know that our community partners, so that's both our local community, the Department of Energy, and the state of Texas are key stakeholders in this next set of growth and, again, low carbon, sustainable design for Seadrift Operations, and ultimately, as we just discussed, for Dow's long-term sustainability goals. So we are excited by the opportunity for this investment and this growth to really demonstrate that. And we look forward to sharing more with you as the project continues in the next phases, and we're able to check off those boxes of permits and construction and ultimately startup.
Well, Heather, you make West Virginia proud. Thanks for jumping on with us here today.
Thank you, Jeremy, for the time.
So, look, we look forward to following this project, and as it moves forward, know that you're welcome anytime to give us an update, and please do so.
We look forward to it.
As always, to our audience, we thank you so much. For more videos, industry news, and podcasts, visit bicmagazine.com. Remember, everybody, it's what we do together that counts.